Doctoral student Robert Pylkkänen at Aalto University is researching how ordinary yeast can be used to produce cellulose without trees or other plant-based biomass.
We're making polysaccharides such as cellulose or beta-glucan, and these reactions can be carried in a test tube, so we can make cellulose in a test tube, which is quite exciting.
In his research, Pylkkänen has used an enzyme that can build cellulose, i.e. polysaccharides, from sugars. In nature, this enzyme unexpectedly does the opposite job. That is, it breaks down wood. This exceptional enzyme was found in a bacterium discovered in volcanic land on the island of Izu in Japan. The research was originally launched as a Finnish-Japanese cooperation project.
Enzyme was isolated from extremophilic bacteria, and what it did differently compared to other bacteria is that instead of using water to break down cellulose, it turned out to be a phosphorylytic enzyme. So it utilized phosphorylases to break down cellulose. And then also this enzyme can be used for the reverse reaction. So if we incubate it in the presence of glucose 1-phosphate, we can make cellulose.
Pylkkänen does not produce the enzyme with an exotic bacterium, but has transferred the genes that control the production of this enzyme from the bacterium into baker's yeast. The material produced by the enzyme amazes researchers. The sugar chains and hexagonal three-dimensional structures it forms are completely unique and not known to be found in nature.
First you have the individual glucose chains that are making like this hexagonal chain, so it's always 6 glucose units per one turn around the helix. Those polymer chains, they come together and make larger structures, and also those structures are hexagonal in shape. But then we see that even those structures come together to make even bigger hexagonal structures, so they are making like multiple layers, and you have huge 10 micrometer in diameter hexagonal structures in the end. But it all starts in the nanoscale.
It is not yet known what all these new materials could be used for, but they could be suitable, for example, for medical use or as an additive to paints to replace fossil-based raw materials. Japanese researchers recently also used these enzymes in an experiment at the International Space Station. The method worked well there because it requires no heat or hazardous chemicals and takes little space. The production of cellulose in space, in restricted conditions, can help us understand what kind of solutions sustainable industrial production really needs in a circular economy.